All right, that's upside down. It says, I will not flip the classroom upside down. What? But that's what we are going to do. We are going to flip the classroom. This class, 6th grade math, is flipped. So what does that mean? That means you will watch the lesson of math on your iPad at home or in your car or somewhere else, and then we'll do the homework in class. So the thing has been flipped, because typically you listen to the teacher in class and then do your homework at home. But we have flipped the classroom. So what do you need to do when you flip the classroom? Well, you just need to watch the video. You need to get out your composition book and you need to take some notes, because I will check the next day to make sure you have watched the video tutorial by the notes that you have taken. Well, Mr. Carlisle, well, how do we know when to take notes? Well, whenever you see the star right there, you see it? Whenever you see that star, that means to take notes. Sometimes notes means just solve the problem. Sometimes notes mean write down the definition. But whenever you see this star, you will take notes. La-di-da. Okay, so let's just move on and let's flip the classroom. So the topic today is the real number system. And there's a star, so you should just write that down, real number system. And we're gonna just talk about the real number system. So we're gonna watch a quick video and then discuss the parts to our number system.
Natural numbers are naturally numbers you count on your hands and your feet. 1, 2, 3, 4, 5, 6, and so on. All numbers are natural numbers plus 0. That's the only difference. Oh, 0, 1, 2, 3, and so on. Integers are whole numbers plus negatives. They look a little bit like this. -2, -1, 0, 1, and so on. Last but not least, not to be irrational numbers are integers and fractions like -3, 1/2, 5/8, and 14.2. All natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers. Now listen to that drummer. All natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers.
So yeah, we'll just stop right there. So what are natural numbers? Yeah, they're counting numbers. 1, 2, 3, 4. When you count somebody on your team, how many team members do we have today? 1, 2, 3, 4. You can count, counting numbers. And what are whole numbers? Well, they're natural numbers plus 0. See? And what are integers? Well, they are whole numbers, 0, 1, 2, 3, 4, but they're also negative whole numbers. -1, -2, -3, -4. And then rational numbers. Well, rational numbers are fractions and decimals that, where the decimal has a finite number, or the decimal can be written as a fraction. I'll go a little bit further into that, okay? So let's just take some notes on that topic there, all right? So let's move back to here. So first thing I want you to do is just, in your composition book, you know, press pause and write down what are natural numbers and what are whole numbers. I mean, it's pretty easy. Remember, natural numbers, counting numbers. Whole numbers, that is natural numbers plus 0. Go ahead, write that down, okay? Press pause. Then the next thing I want you to write down is, well, what is a rational number? Well, look what the definition says. It's a number that can be written as a fraction. So do you see this? That's a rational number. Oh, look, my thumb. This is a new Promethean board, and I can write with my thumb. Weird. But 3 1/2 can be written 3.5, right? So a rational number is a number that can be written as a fraction. For example, 1/3, you can write that as 0.3333333333333. A decimal is a rational number when it terminates or it repeats with a pattern. when it terminates or it repeats as a pattern. That's a rational number. And I'll go a little bit further. But press pause, write this down too. So, let's talk about this when the decimal is terminated, okay? I'm Arnold Schwarzenegger, the Terminator. That's a bad impersonation of Arnold Schwarzenegger. Plus, you probably don't even know what movie I'm even talking about right now. But terminating decimals, okay. So this is a terminating decimal. What does that mean? It ends, can I do this? No, can't do that. All right, I'm learning this Prometheus board. Okay, so let's try this again. Okay, so a terminating decimal has a finite, that means a certain number of digits after the decimal point. For example, 1/4 equals exactly 0.25. Exactly. If you do the division, if you divide 4 into 1, you will get 0.25. Okay? A repeating decimal is a fraction. When you change it to a decimal, it consistently repeats. Like if you change 2/3, you would get 0.666666. If you change 1/6, you would get 0.166666666. Okay? So those are rational numbers. Rational numbers can be written as a fraction. All right? And they can also be written as decimals. And they are rational numbers as long as they terminate or it repeats. I hope this makes sense. Okay. So here's all I want you to do. Press pause again and write these problems down. And then next to the number, just tell me, is it a natural number? Is it a whole number? Is it an integer? Is it a rational number? And some of these answers will have more than one answer. Some of these will, okay? So press pause and do that, please. And we'll go over this during class tomorrow. And let's see here. And the other thing I just want you to do is, so the one thing we didn't really talk about is irrational numbers. Irrational numbers. So if you look at this chart, whole numbers are natural numbers, whole numbers, integers, rational numbers, and then here's irrational numbers. Well, irrational numbers are numbers that where when you write it as a decimal, it doesn't terminate and it doesn't repeat. And the perfect example of an irrational number is pi, right? Because pi, if you write down pi, it equals like 3.14, and then it just keeps going and going and going. It never terminates and it never repeats. For example, if you found the square root, probably should change this color. If you found the square root of 8, it's probably like I really don't know the exact number, but it's probably like 2.14672. Doesn't terminate, doesn't repeat. So those are irrational. It's just irrational. Don't do that. Okay, so I hope that makes sense. So all I want you to do is give me your definition of the difference between rational numbers and an irrational number. And that's it. That is it. So that wasn't too bad, right? The video tutorial was like, I'm looking at the clock right now, it was 8 minutes and 36 seconds long. My tutorials are usually always less than 10 minutes long. And what we'll do tomorrow is we will talk about this topic a little bit further, and then you'll get your classwork. And you'll get your classwork and you'll work on it in class, and you should finish it in class. So your only homework for me is to watch videos. And you can do that